All right, this is Mr. Gillum, and you are in for a treat today. Today, we are going to, you ready for it? We're going to add fractions together. Yep, you guessed it. We're going to add and subtract fractions. We're going to add those positive, negative numbers in there. Same signs add and keep, different signs subtract, the whole shebang, except for with fractions now. All right, so we got a lot to learn, and I want to make this video nice and short and sweet so we can practice, practice, practice. So here we go. Adding and subtracting fractions. The dreaded fraction. It's not going to be that bad, don't worry. Basically, here's how it works. In a fraction, the bottom number, or denominator, represents the number of sections that one unit is divided into. Whoa, whoa, whoa. Yes. Yes, boys and girls. The number of sections that it is divided into. Okay? Number of sections one unit is divided into. The top number represents the number of the number of parts of sections. All right, so the number of divisions being referred to. So the number of divisions divided by the total number of sections. All right, that's how a fraction works. And I think that all gets kind of lost in the translation from elementary to middle school and so on. I think that gets lost. Okay, so just remember, 5/6, we're talking about 5 of the 6 parts. 1, 2, 3, 4, 5. We're talking about 5 of the 6 parts. Okay, 5, 6. 6 is the number of divisions, and we're talking about 5 of them. All right, so that's how fraction works. Just a reminder, that's how it works. Okay, so if we have more, if we're talking about like 7 of the 6, if we have something divided into sixths, there would actually be 7 of them. 7 of the sixths of the one unit. So let's just take a look here. Learn some fractions. There we go. Okay, adding and subtracting fractions. So here's what I want to do. I want for you to have a nice visual aid here. So what I'm going to do is I just want you to divide this little hexagon here, little 6-sided figure, into sections, nice even sections, and I just did that by connecting the points. And so what you see here is I have 6 sections. All right, and let's just for argument's sake, let's color in 2 of the sections. Okay, so I have 6 parts for this fraction, or this division of this one hexagon. I have 6 parts, and I'm referring to 2 of them. And now I have this other hexagon over here, and once again, let's divide it into 6 parts, 6 even parts by connecting their interior angles. And let's just, for the sake of having a nice example here, let's just shade in 3 of their regions. So I could represent this fraction as, of the 6 parts, I'm referring to 3 of them. Now, together, addition, together, how many parts am I referring to? Well, I'm referring to 2 of the 6. So let's just make our last diagram here. Oops, I completely airballed that. Let's just make our last diagram here. And I'm referring to 2 of the 6. Plus I'm referring to 3 of the 6. And so together, I'm referring to 5 of the 6 parts, okay, of a unit that is divided into 6 pieces. So 2/6 plus 3/6 equals 5/6. So let me just show you what it looks like here. 2/6 plus 3/6 equals 5/6. Now, I want you to pay close attention to the top and the bottom numbers. Our number of divisions that we have of our one unit didn't change. We had of the 6 divisions, we still have 5, referring to 5 of the 6 divisions. We had 2 plus 3 equals 5. So notice the pattern here. Does the bottom number change when we add? Does the number of sections change? No, it doesn't change at all. We're still referring to 5 of the 6 sections. Okay. On the top, we had 2 here, plus 3 of them here. So total we have 5/6 of a hexagon represented. All right, so let's take a look at another one then. Squares, my favorite. I love squares. Okay, let's change it to purple. And we're just going to divide these squares into fourths. I'm just going to connect these edges here. And once again, let's just make it simple. Let's just start with this square. I have 4 pieces total, and I'm referring to 1 of them. And this square, let's just do 2 of them. I have 4 pieces total, and I'm referring to 2 of them. Now together, this guy plus these two guys would represent 3 of the 4 divisions. And so when I write it out, if I put these two rectangles together, 1/4 plus 2/4, I know would equal 3/4. 1 plus 2 would be 3. The number of divisions didn't change. I still have 3 of the 4 divisions. All right. So the bottom number, the denominator, is not going to change. It still represents how many of the total pieces of one unit that we have. All right. Here, I think. Ooh. If I asked you how many more divisions in this one than this one, if there's 2 divisions here and only 1 division here, then this would be 1 more. Or I could say 2/4 minus 1 of the fourths equals 1/4, 1 of the 4 divisions. This has 1 more division than this guy. He only has 1, he has 2. So subtraction works the same way. I have 2/4 minus 1/4 is 1/4. Okay, there's 1/4 more. So it works the same way with subtraction and addition. Looking at triangles, I'm just gonna do bisectors here and draw that angle right to the other side. Oh man, okay, that didn't really work out very well. Let's do this instead. Let's just find the middle point and I'll just connect them. How's that look? Now I'll just throw a little tool in there, a little trick for you. If I had 1/3 here and I separated this one into 6 parts, so 1, 2, 3, 4, 5, 6, is 1/3 the same as 2 of the 6 divisions? Yes, it is. So that's something we need to keep in mind for tomorrow when we start adding fractions with different denominators. Okay, so 1/3 and 2 of the 6 parts are essentially the exact same amount of 1 unit. And that's where the reducing comes from, because we wouldn't want to say 2/6. We would say it's 1/3, because 2/6 is too complicated. It's too much, too big. The numbers get too large. So that's why we always reduce 2/6 into 1/3. They are the same thing. Okay, and so instead of saying 1/3 plus 2/6, what we're going to say is 1/3 plus 1/3. Even though this represents 2/6, we know 2/6 is 1/3. It's the same exact thing. So together, and once again, we'll make our little diagram here. If I have 1/3 from that guy and 1/3 from that guy, I have 2 of the 3 divisions. So even though I have 2/6 on this one, it really is the same area, same amount as 1/3. And 1/3 plus 1/3 is 2/3. So hopefully you're starting to get it here. Now we have these nice little circles on here. I'm going to do a subtraction problem this time, like a legitimate subtraction problem. So I'm going to divide this into 8 pieces. Divide this guy into 8 pieces. And this guy into 8 pieces. All right, and I'm going to say that this has 3 of the 8 pieces used. So I'm going to say this fraction is 3/8. I'm going to say this fraction is just 1/8, represented by that much. Now, if I ask you how many more pieces are shaded in, you can probably tell me right away, well, if these two cancel out, this guy cancels with him, this guy still has 2 left over, so the answer is 2, obviously. But in the math world, we need sentences to represent this. So I would say that 3/8 minus 1/8 would equal 2/8. But now, look what happened. Look what happened. 2/8, really, if I outline this into 4 pieces, see how I just have 4 pieces? Honestly, 2/8 is really just 1 of the 4 pieces. So really, 2/8 is 1/4, and that is important. That's very, very important, because we wouldn't want to say 2/8. We would want to reduce it to 1/4, because 2/8 and 1/4 are the same exact thing. It's going to be really important tomorrow when we add our fractions at different denominators. So now, let's just think about this little problem here. It says Michaela ate 7/12 of her orange before lunch and 4/12 of her orange after lunch. How much did she eat total? I think is what it said. I think I accidentally cut off the last word. How much did she eat total? So let's just see here. If I have 7/12 before lunch, 1, 2, 3, 4, 5, 6, 7. That leaves me with 1, 2, 3, 4, 5 12ths left, right? 7 12ths are gone, and now I'm eating another 4 12ths after lunch. How much of her orange did she eat? Well, she ate 11 of the 12 pieces. So this is what I want to start getting at. 7 12ths plus 4 12ths is 11 12ths. We're adding the top number and we're leaving the number of divisions the same. So 11 12ths would be our answer. 11 12ths of the orange. I guess I should have written that in orange pen, but there you go. Okay. Finally, we need to convert a mixed number into an improper fraction. Okay, and so there's two steps. The first thing I want you to do, and this might not be the way that you've learned before, but this is the way we're going to practice because this is actually why the little pattern works. What we're going to do is we're going to change the whole number into a quotient with the denominator matching the fraction's denominator. Now, that sounded really, really complicated. However, it's not that bad. So I want to just look at this whole number here, 3, and I want to make it into a fraction with a denominator of 4. Okay, because this is 3 and 1/4. I would like for them to both have the same denominator. So what could I divide by 4 that would equal 3? Is 12 fourths the same as 3? Is 12 divided by 4 3? Yes, it is. And so I know that if 3 is the same as 12 fourths, and I know this little division bar is a fraction bar, means divide, then I know together I have 13 fourths. And there you go. And the reason that I want you to do it this way today is because this skill is going to be important tomorrow as well. It'll be very important tomorrow. So even if you know another trick or another way to remember, I want you to practice with the common denominator. Okay, so let's look at the whole number again. And if I want to add things in thirds together, I have this 1/3, 2 and 1/3. I need to add two fractions with the same denominator of 3. Now I know that 6 divided by 3 would equal 2. So 6 divided by 3 could also be written as 6/3. Because they're equal, I can just write it differently. Okay, so 6/3 plus 1/3 is 7/3. And now it's my improper fraction. Okay, and like I said, I know there's tricks to it, and I know the tricks, thank you very much, but we need to practice getting these denominators the same. So I want to change this 1/8 into something over 6. Something over 6. So what I'm going to do is this. What could I divide by 8? Sorry. What could I divide by 6 to equal 8? Well, be 48. 48 divided by 6 equals 8. So 48 sixths plus 5 6 is 53 sixths. And that's my improper fraction. Okay. And finally, 10 and 2/5. If I want to add my 2/5 to 10, I need to think of something divided by 5 that will equal 10. 50. Therefore, I know that 52/5 is my improper fraction. So when I say 10 and 2/5, or 8 and 5/6, or 2 and 1/3, or 3 and 1/4, I'm really just adding two fractions that are different. Now I just want to do one more illustration for you here. Let's see here. Let's do this color, and I'm almost done with you. What I'm going to do is this. If I had 3 and 1/4, that's saying I have 3 and 1/4. Now, since I need 1/4 of this guy, I'm just going to divide them all into fourths. Now, we would all agree that I have 3 and 1/4 here, but really I have 4/4, 4/4, 4/4, and then 1/4. So 4 plus 4 plus 4 plus 1 is 13/4. And the same thing goes for 2 and 1/3. I have 2 and 1/3. But really I have